Hi everybody, welcome to another YouTube video, and this one today we're going to have a look at the 20 kilowatt hour Libbi battery storage system that we fitted today. There's a ground source heat pump that we didn't install but this will be interesting to look at. We changed their solar PV inverter, which is feed-in tariff registered because that one had gone faulty. We've done a full smoke alarm system with heat sensors as well in the property. There's loads to go through and I'm really excited to show you it. Come on, let's go and have a look. Okay, so let's start in the garage. This is the main thing that we've done at this property, and we've installed this 5 kilowatt, 20 kilowatt hour Meinergy Libbi battery storage system. Now, the couple of reasons we chose the Meinergy Libbi, the customer already had a Zappi EV charger, which is also made by Meinergy, so a lot of the infrastructure was already there. The customer was already happy with the app. The app is fantastic anyway, so it's good to just integrate another piece of equipment into that app. And the customer's already happy with it, so that makes it easy. The other thing is that we really do like Meinergy. They're a British company as well, British tech support. Yeah, and it's when things go wrong that a company is tested. And so when equipment does go wrong, Meinergy are there to help, which is really good. So this is the setup, obviously. Like you can see, we've got the inverter at the top here, and then we've got the 4 battery modules. So 5 kilowatt inverter, 5, and then a top cover just there. So this is the biggest that the Meinergy Libbi can go. So we've got 20 kilowatt hours of storage here. Just under that is the usable capacity, but it's thereabouts 20 kilowatt hours. And then we've got some other equipment just on the side of this here. So we've got the Meinergy Libbi controller, which is just to the side here, which we'll go through in a bit more detail in a minute. We've got the switch fuse that powers the Meinergy Libbi controller, as well as this little Eco SmartLink box, which we'll go through in a minute. And then we've also got this AC isolator here, which is the local isolation for the Meinergy Libbi battery. And that's just a rules thing to make sure that we've got that local isolation. We've then got our normal document holder with our schematics and the Libbi manual in there as well, and that's there for as well if customers want to put their handover pack in, you print it off and put it in there, then that's absolutely fine, or any other documentation. It's just nice to have that so that you've got all that information there. You can see here we fireboarded the wall as well. We've added this extra fireboard up here, 1 to carry this trunk in, but 2, customer is considering potentially having another solar PV inverter in the future. They've got a little bit of they've got a very nice garden out the back that's got plenty of space, so they're thinking of potentially having a small little ground mounted system out there. There's 2 ways that could work. We could either feed the solar back into here, and I'll show you the connections in a minute as to how that might happen, or if the system out there is too big for what the Libbi can handle, then they could have a secondary inverter like a solar edge inverter or a Solace or something else. But we've left that space available so that it's nice and easy to come off to the side with the new inverter and all the isolators. We've also made sure that the cabling over to this is oversized so that we can effectively put a little consumer unit here using that supply cable and then feed the Libbi from it and feed us another inverter in the future. That might be another video if and when that happens. But what I want to show you now is I just want to show you the connections on the Libbi, how all the isolators work, where those solar connections are, and just run through how we've connected all this up. So let's have a look at that now. Okay, so let's have a look at these connections now. Let's see if I can get this lid off. Just there. So inside here is where all the magic happens. This is our main supply in, so this comes from our AC isolator, so this is our route in for the power. So if we want to charge this battery because we've got surplus solar power, or we're looking to charge this from the grid, then this is the route that power takes to come into the Libbi and therefore into the battery modules. If the Libbi needs to discharge back into the house because it wants to supply the loads in the house, or it wants to force power back to the grid, then this is the route the power would use as well. So that one route does both functions. This plug here isn't used at the minute, but this is the backup plug. So this could go to a little distribution board that might have some essential circuits in, like, you know, Wi-Fi or fridge freezer, things like that. But this isn't used, but we left the plug there in case that ever is used in the future. Just behind all of this, we've got a couple of MC4 connections. So we've got a dual tracker solar inverter within this system. So if you wanted to, like I mentioned, add solar to this in the future, then effectively we could have two strings of power, so maybe like an east-west setup coming into this inverter, and that would mean that this Libbi inverter could be used as a solar inverter as well as the battery inverter. So it would go from what is currently an AC coupled system, which just means that the battery sits there as its own entity, it doesn't have any solar going directly through it. It would change from an AC coupled to a hybrid system, and that would mean that it sits there doing its own thing, but it also has solar PV feeding directly into it, so it'll deal with the DC side of the solar as well. We've then got an earthing connection here, which just earths the battery modules and the inverter and links it all together. And then we've got the battery BMS cable just here as well. So that goes down to the batteries and basically feeds the information from each one of the battery modules BMSs, which is battery management system, into the inverter, so that the inverter knows that everything's okay, what the state of charge of that individual cell is, what the cell voltages are, all the different information that the inverter needs to know to keep those, in this case, 4 battery modules nice and healthy. So there are all the connections in the back of there. If we have a little look in here, these are I think they're IP56 from memory. I'll double check that in a minute. So this has this sealed cover here, just to keep any moisture out if this is to be installed outside. But we've got our battery switch here. So this is a DC switch. It's 125 amps, and that will isolate these battery modules from the inverter if you need to. We've then got another one here, which is a load switch. So this is actually for the backup supply. So this is off at the minute because we've not got that backup supply on the system at the minute. But if we were to use that and we had a little distribution board supplying some other circuits, then this would be on, and that would energize this plug that we haven't used in this case. We've then got a ProJoy DC isolator. So again, if we had solar PV feeding directly into this through those MC4 connections that I mentioned, then this would be on, and that would allow the DC to enter the Libbi inverter, and this is just a local means of isolation. We would also have another one of these, or another 2 of these, depending on how the system was set up, on the outside of the inverter, but the inverter comes with one inside it as well. That's there. Great, so I'll seal that back up, not that we necessarily need it in this garage, but it's all there. And then what I'll do is I'll swap with Dan the video man. If we just have a look down that left hand side, you can see we've got the DC connections here. So this is basically connecting the batteries into this isolator that we've just seen and delivering that energy from the batteries into the inverter, or from the inverter down into the batteries, depending on which way the current needs to flow. So yeah, that's how these are working. So you can always tell with the size of the leads as to if they are low voltage or high ampage, and therefore high ampage batteries, or if they're high voltage, low ampage batteries. When you've got chunky leads like this, it means that you've got high ampage batteries, low voltage. So I think these are around the 48 to 50 odd volts, 52 volts. I can't remember 100%, but the ampage is much higher, and that's why these battery leads are really chunky. For another system like the Solar Edge battery, we can basically use a 6mm solar PV cable there, because the battery is very high voltage on the Solar Edge side but low ampage. So that's just an interesting one, that if you see some big chunky battery leads, you know that you've probably got, or you're probably fitting, a high ampage battery, low voltage. So, and there's a cover that goes all the way down here that is screwed in, which locks away the terminals onto the battery, so that they're locked away so no children can kind of play around with those. There are some systems on the market, and usually quite cheap systems to be honest, that all these connections are visible, and that, you know, children or people that aren't informed can actually start playing around with these. And if you were to pull one of these out when one of these batteries was charging, then there would be a hell of a spark and it would probably be quite dangerous. So it's important, and it does mention in PAS that these terminals are locked away. So that's why we like the Libbi, because it's got that already in place, which some other systems do, but some definitely don't as well. So yeah, that's the connections inside the Libbi. Okay, so I've just had a little look, and it is an IP65 battery module or battery system. So this could be installed outside in most cases. So it's always up to the electrical designer to decide whether or not this can be installed outside and the location that it goes, but it's got a really good ingress protection level of IP65. So yeah, for most scenarios it's fantastic. The only thing that we have to be careful of is the little controller. That isn't IP65, that's probably IP20 or IP40, something like that. So that would need to be inside somewhere, but in most cases that's fairly easy, because we've got to get the electrics inside anyway somehow to get back to the consumer unit. So yeah, that's a bit of an overview of the Libbi. We've obviously got the state of charge lights all the way up here, so you can see this light here is flashing, so we're on the 3rd bar there. We'll have a look at the app a little bit later on in the video to see where we're up to on the state of charge there, but you can see they're all matching, which is good, means the system's balanced. We've not got any fault lights, we've just got the green energy light, which is good. So yeah, that's a bit of a run over of the Libbi battery system itself. I'll show you the little controller next, and some of the other bits that we've got on this side. Okay, so this is the Mind You Libbi controller. So this part here is kind of like the brain of the full system. So this device here brings the battery into the app. It provides the battery with all the information and the commands from the app. It's basically the gateway for the system into the Mind You ecosystem. I will have a quick look at the icons on here to work out what all these show you. If you've got a Zappi, or you've got an Eddy, or any of the other products from Mind, you'll be used to seeing these icons, because the screen is basically replicated from all of those other devices. So we've got this top left, we have got the sun. So this is the amount of solar PV that we're generating right now. Luckily the sun's just come out, so we've got a nice 2.5 kilowatts coming down. And this is the feed-in tariff registered solar PV system that's already been installed at this property. So that's been fed down into the property's distribution board. We've got a CT clamp around that, a current transformer around that feeds back into this ecosystem, so that the battery and the Zappi know what the solar's producing. The house is using in total around 1 kilowatt, so 1 kilowatt of energy, and probably most of that is probably the ground source heat pump. This is the grid, this is the key one. We were using 1 kilowatt in the house. We're generating 2.5, but yet nothing is happening to the grid. Sod's law, there, it just kicked in. But there we go. So nothing is happening, and the grid is not importing, and we're not exporting to the grid. We then drop down to here. This is the battery. So you can see you've got charging in the middle there. So the battery is now charging at around 1.4 kilowatts. So 1.4 kilowatts is going into the battery at the minute. So we're charging up, and the battery state of charge, those battery modules that we saw earlier, are collectively 47% charged. So we're nearly 50% charged on this. The customer does do a nighttime charge as well, because we're on a split tariff, so they charge the battery during a low tariff window overnight, because they do use so much energy with the heat pump. Like this 1 kilowatt is pretty constant throughout the day, so having that extra power overnight is really handy. You'll notice that things jump around all over the place, so the grid keeps clicking in. There's a little bit that goes back to the grid and stuff like that. Well, one thing to remember with battery storage systems is that the battery can't watch you walking over to the kettle or to the oven or to the hob to turn it on. It has to physically see that demand happen, and therefore have some grid import to actually start either charging or discharging. So in that case, discharging to remove that consumption from the grid and actually put it onto the battery. If the sun suddenly came out and there was loads of excess solar power, then you might see a little bit of export back to the grid as well for a short time. The battery would then see that, and it would ramp up the amount of power that it was looking to put into the battery. That's kind of the overview of it. We've got the time and the date there as well, but that's kind of the overview of the system on this main screen. But if we click on the menu button, we can go into some other menus. So if we look at readings, we can see here that things are broken down a little bit more into per watt. It's more about now giving you the per watt reading rather than on the main screen where it rounds things up and down to the nearest 100 watts. But if you want to see it in a bit more detail, then you can see it just here. So we've got the amount of power that we're charging with. We're exporting a little bit of power, but you can see that drops, and then it'll probably come back up again. It's dropped a little bit further. It's gone back up. So the solar is generating different amounts every second, based on the light levels and the voltage. So we've got current there as well, so that equals about 5 amps that the battery's charging with. State of charge is 53%. The voltage, the live voltage coming from the grid, is 239.5 volts. This next bit is a really interesting part for us electricians, but also for you as a homeowner. If you're watching this as a homeowner, we've got voltage max and voltage min. So these readings here will indicate if your voltage is kind of spiking really high, because sometimes we do get these issues where, especially in the countryside, where the voltage will spike really high or drop really low, and the batteries have preset levels that they can operate in. They've got a kind of like a voltage range that they can operate in. It's usually kind of around the, I think it's around the 220 to 255, something like that. Those voltage ranges allow the battery to synchronize with the grid. If it goes above or below those levels, then the battery will fault out, and sometimes that does happen. And so to go to this little section here will allow you to look at it and go, okay, well, we're hitting 260. It might only happen for a second, but it's happened, and the battery would fault out in that case, or it might drop to 200 volts, and the same thing would happen, and this will log it. So that's a really good reference point there. We've then got frequency around 50 hertz that we normally would see. We're now and we're exporting again 117 watts, and then we've got a grid current of 2. We can see our generation again. So there's loads of information on here that we can run through, but a lot of it is really just the first section, which is showing you the per watt figures rather than just the rounded figures. But the rounded figures are good enough for the day-to-day kind of workings out of how the system's doing. Information, again, we're looking at firmware versions, how the grid is wired in, lots of other information in there as well. Link devices, we can see what the other devices are on the system, and also device settings as well. So we can have a look at the time and date, firmware update, and all this other sort of stuff. So lots of stuff in there that we can do, but I won't go into that because it's a bit more technical than this video is designed to be. So there is the screen, and this is the Libbi. Like I said, this is kind of like the brain of the full system. This is where the internet connects in as well. So we bring our internet connection here, or we connect via Wi-Fi on here. So yeah, that if this is inside, and that makes life a little bit easier in that case. So I've just realised that I've got so preoccupied with showing you the battery storage system and not actually showing you how we got the cabling in. So in this trunking here, that obviously goes up to the ceiling. We've then got another piece of trunking that runs along here, and inside that we've got the supply cabling to the Libbi. And like I mentioned right at the start, we've oversized that to give us the potential capacity to put a distribution board on here. So it runs in that trunking, and then actually behind this vent pipe, it looks like a saw pipe, but it's actually a vent pipe, there is another piece of trunking that runs to the end wall. And then over to that end wall, you can see just the cable just sticking out the wall as it flies up into that trunking, because it was very, very tight over in that corner, but we've made that as neat as we could. We'll go into the utility next, and I'll show you how we then ran that cabling in once it's gone through that wall. So let's go into the utility now, and we'll have a look at that. Okay, so we're in now, kind of like a secondary utility area. So we've been through that other one where the cabling goes through the boxing. We've then got the final piece of boxing that runs along the top here. We've got our AC isolator, a bit like the one in the garage. We've got our AC isolator here that will disconnect the battery from the main electrical supply, which again is a requirement when these systems are installed, so that electrician, if they want to work on this board, they can locally isolate the battery from here if there isn't access to the garage, or they're just lazy. Either way, they've then got a local isolator just here. So that then feeds through that isolator into this board, and then we've got our circuit here for the Libbi. The solar also feeds in here. It's this one just here, which is like I say, a pre-existing installed solar PV system, but we've got our CT clamp on that circuit there, so that the battery and the Zappi know what the solar PV is doing. That's all nice and neat, and this then is really the way that the battery can then, if the house needs more power because there's not enough solar to supply all these circuits, then the battery will pump the power down through the isolators and then into this board, and it'll backfeed these circuits. And it'll mean that the grid isn't needed to import anything to support any of these circuits, because it's getting its power through this MCB here. If the solar is producing far too much and the house can't use it all like it is now, then what happens is the power comes through from the inverter in the loft, comes through this breaker here into the system. The system can see that power being pumped back down and out to the grid. So the Libbi inverter turns on to the amount of power that's going back to the grid, and effectively creates a draw on this circuit to charge the battery, and that then kills that export back to the grid. And it's doing that, it's changing that figure literally every few seconds. So it's doing a lot of work there to try and make sure that this main switch is effectively not having any current go through it, not exporting anything and not importing anything. So this is probably a very low ampage draw through it now, apart from overnight when it's pulling power in. We've also got all of our documentation on here. So we've got another schematic, another start-stop procedure, dual supply label, dual colours label, RCD test label. Everything's in there, and we've tried to keep it as neat as possible. Yeah, so that's everything over here at the DB end. So next, we're going to have a little chat about the smoke alarms. Okay, so now let's have a little look around this property, and I'll show you what we did to get these smoke alarms in place. Now, before we do that, I just want to touch on this a little bit. Putting the smoke alarm cost in our price costs us jobs. The smoke alarm side of things effectively makes us more expensive than a lot of other people on the market, because we want to do this job correctly using all of our professional experience, and we look at all of the guidance out there. So the PAS, publicly available specification, I think is what it stands for, 63100, states that a home, if they're having a battery energy storage system installed within their electrical system, should have an up-to-date and compliant smoke alarm system within the property. Now, many installers are ignoring this because it is more cost, it does push their price up. But for me, if one of our customers or prospective customers comes to us and wants us to do a job, then I want to leave them with a job that has been done properly, considered all the guidance, and ultimately has upgraded the safety of that property. Yes, it does add cost to the job, but in comparison to the cost of doing the solar or the battery storage system, it's a drop in the ocean. So that's why we are doing that. It's one of our company red lines. We are now making sure that all properties do have that in place. So if you do come to us wanting a solar and battery storage system, then do expect that to be in there, because we want to leave you and your family, when you're introducing something that is an extra risk in the property, that insurers, I do think, will be tightening up on this. Having it installed done by us will mean that you're left with a compliant system. So anyway, that's my little pitch before I show you what we've done here. So like I mentioned, this property had Nest smoke alarms. They weren't wired in, they were just 10-year lithium, which is nice and easy to install, but in England they have to be mains wired and battery backup. So let's have a little look now. So if we come through here, there was one here originally. So we are using the Eco smoke alarms because they are just the best, to be honest. Certainly domestically, they're the best ones out there. So if you do have a different type of system, then the chances are we're probably going to change them out for the Eco smoke alarms. But if the wiring is already there, then that's great news. So we've got one here, which is kind of the landing area, the entrance area. So it's protecting this escape route down your stairs and outside. So it's an important one to have just here. If we come into the kitchen, so we've got a multi-sensor here, which has also got carbon monoxide, because we've got some gas appliances in and around here. So that's a multi-sensor again, so heat and smoke, but also the carbon monoxide. So even though it's heat and smoke, if you were to burn some toast, which we're all familiar with, and the smoke alarm goes off, if it senses the smoke but not the rise in heat, then it won't go off. So that's why we like to use the multi-sensor ones, because it's like a dual. It prevents any kind of nuisance alarms, really. It looks for multiple different things happening within there. Obviously, if it gets smoke and it gets a lot of heat, then it knows there's probably a fire and it'll go off. Now, these are all interlinked around the house, so if this one goes off, then they'll all go off. And if they all go off, you are definitely not sleeping through that, which is what we want. So that one there was an existing one just over there, which was just an optical, like a smoke alarm. I think we What did we do with that? Did we put a multi-sensor? No, we changed that just for an optical. So we've got an optical there, 10-year lithium on them all. We could use the 9-volt battery range rather than the lithium, but for me, if we're going to the expense of changing these, we might as well give you one that you don't have to change the battery in at all, because we don't want it beeping, and you need to find those little D-type batteries. So yeah, we've got 2 in here. We had the one in the utility, and then we've got another one at the top of the stairs. I won't show you the one at the top of the stairs, it's just another alarm, but we've got now a fully protected house within this property. Now we've got a fully protected house that is now protected. If there was a fire and that fire reached the battery, then this family will be well out of this house before anything like that happened. Now, one thing to bear in mind is that this isn't about putting smoke alarms in because the batteries instantly combust or anything like that and cause house fires. I don't think there's any reported cases of that happening, certainly for home battery storage systems. There has been some scooter fires and things like that where people have stored their electric scooters and stuff in houses, but it's more about if you have a kitchen fire or a fire in your garage because you've left something going or whatever, then it's making sure that you and your family can get out of that house before the fire reaches that battery. If fire reaches any lithium battery, you want to be well away from that property. So having this smoke alarm system in, that's why for us it's so important. Having this smoke alarm system in means that you and your family are out of this house well before anything reaches that battery and causes that fire to get worse. If fire reaches that battery and you're still in the house, the amount of smoke that will be put into that property instantly when that lithium combusts will make the house fire so much worse. So it's not something to prevent you getting one, but it's what I'm saying to you is if you're going to the expense of getting a battery storage system fitted, then make sure that you've got a good smoke alarm system in, which probably should be in the property anyway. So take the opportunity, take the VAT relief, and actually get this fitted during the point of doing all this work in your property anyway. Right, now we've done the house bit, we'll go back into the garage and I'll show you what we've also added into this on the smoke alarm system to make it just that one little bit better. So let's head back to the garage now and I'll show you. So there's a couple of things that we've added into this system that not every system might want, but is a good one to kind of show you in case you're a customer watching this and you're considering having a battery storage system with smoke alarms. Hopefully I've convinced you to get smoke alarms as well. One of the extra little things that we can add, or your installer can add, is one of these Eco smart gateways. So this connects to the Wi-Fi of the property, and then each individual smoke alarm has a little RF module inside, so basically like a radio frequency module inside, and that not only interlinks all of the alarms together, so that can be done via like a hardwired route with a 3-core cable, but if we're having to say like this one in here, this alarm in here, we had to tap off a lighting circuit to get it, so we didn't have a hardwired connection to the next alarm, then what we can do is you can use these little RF modules inside which allow those alarms to talk to each other. So we can do that remotely, we just can't power them just on battery. If each alarm has one of those little RF modules in anyway, regardless if you've got the cabling there, then they can all talk remotely to this little smart gateway. And that means that you can get the Eco app as a customer, and we can see it as well as an installer, and you can remotely check the health of all of your smoke alarms. It's really good for rental properties, and that's mainly why this has been brought out, but we've decided to put some of these in our installs as well, because you've got an app for your battery and now you've got an app for your smoke alarms. Because there is an introduced risk of having battery storage within your property, even if there's battery storage systems outside of your property, having a good smoke alarm system is important. So we thought, well, everything's going on an app nowadays, this adds a couple of £100 to the price. Having this in place means that we can, or you can, remotely have a look at how healthy and how well your smoke alarm system is covering your property. So we've included that on this one, and that links all those smoke alarms onto the app so the customer can check the health of them, which I think is pretty cool. Okay, so just to finish off this smoke alarm section of this video, we've got our multi-sensor alarm just up here. So that's obviously covering the garage. And what we also trialled with this one is a temperature and moisture sensor just up on here as well. So this detects mold and humidity and what have you. Again, really well placed for the rental sector to make sure that places are you know, not getting too damp and mouldy and what have you, and also feeds all that information onto the Aco app and Aco dashboard for the client or for the tenant or for the landlord. And for us, it just meant that we can see that this room isn't getting too hot with having the ground source heat pump in here, as well as the battery, and obviously he's got his motorbikes and lots of other things. So it just meant that we can add some more information to that app. So that's the roundup basically of the smoke alarm system and kind of the ecosystem that we've put in this property, which I think is really good. And like I say, that's something that we're fitting on all of our battery projects around the country. Okay, so what I thought I would do is I'll just show you this screen on the ground source heat pump. So I won't take you through the full ground source heat pump because we haven't installed it. I'm not a plumbing and heating engineer, so I don't want to tell you anything that isn't true. But what I've found on here is the consumption, the electrical consumption that this ground source heat pump has or has been reading. So we've got a couple of different things here. We've got the amount of kilowatt hours that this is used to heat the property today, and then the heating total there. And then we've got the domestic hot water there, and then the total amount of kilowatt hours, or in this case megawatt hours, that it's taken to heat the hot water. So obviously, like with air source and ground source heat pumps, which we're all looking more at now, they're electrically driven. They're efficient, and so you get a lot of heat out for your power, but we are using electric for everything pretty much now, and things are going more towards that. So this one here, you can see heating today, this top one, just today, and currently it's 11:24 in the morning. We've used nearly 2 kilowatt hours of electricity for the heating. We've then, in total, I assume this is total since installation, I hope it is, this ground source heat pump has used 21.199 megawatt hours. So that's a hell of a lot of power to heat this property. We've then got the hot water, so it's used nearly 5 kilowatt hours today to heat the hot water for this property, and then in total it's used 6.757 megawatt hours electricity. So that's a lot of electricity, and that's why having the battery storage is good, because it can help balance the solar to provide these daily figures of electricity. It can help to supply this heat pump with energy when it is needed to either run the hot water or run the heating. That might not happen whilst the sun is shining, it might be at night. So when that's happening, the battery can then discharge and actually supply this heat pump with power to try and reduce the grid import to supply this heat pump with power. So that 4.768, quite a lot of that has probably come from the battery or the solar or an off-peak tariff. So the battery is there to try and balance out the demand that this heat pump needs and trying to supply it with as much solar power as possible. So yeah, I thought that was interesting just to see how much energy this ground source heat pump has actually used in total, but also during the days that it's been working. Right, so we've nipped around the back of the property and we are literally about southeasterly facing here, and you can see we've got some solar panels on the back of the house. So this is the original feed-in tariff registered system, probably done in 2010-ish, something like that. So done quite a while ago, and they're registered with the feed-in tariff. So basically get paid to generate. I'll go into that a little bit more in a minute. But this is kind of a classic setup, 16 panels, all on one roof, feeding back to a 3.6 kilowatt inverter, and basically earning money from having that solar PV system on your house. So the feed-in tariff was a scheme brought out by the government where they paid you to generate. The actual name feed-in tariff is a rubbish name, to be honest, because that indicates, or that implies, that you only get paid for whatever is fed back into the grid. It is actually a payment just for generating the power. So if you generate 100 kilowatt hours, you get paid for 100 kilowatt hours. So right at the height of it, it was about 43 pence. So just to generate power, you got paid 43 pence per kilowatt hour. That's now near 60, 70 pence now because of inflation. So it's an unbelievable payment. Even if none of that 100 kilowatt hours goes back to the grid, you still get paid the same. And what they had at the time as well was something called a deemed export tariff. Because the metering wasn't really there and nobody had smart meters, they couldn't meter how much you were actually exporting back to the grid. So what they did was they said, okay, 50% of whatever you generate, we'll give you on top of your feed-in tariff, so that 43 pence figure, if that's when you joined it, we'll give you an extra 4 pence, because we reckon half of whatever you generate, you're sending back to us. Madness. So people are on a lot of money for these systems, and that's where we're seeing people reinvesting some of that now into battery storage. Because if we quickly do the maths, if you're on, say, 70p now, let's be optimistic, 70 pence per kilowatt hour of every unit you generate, if you generate that power, get paid 70 pence, if you store it and use it, you're saving your grid import cost at, say, 30 pence, I'm rounding, but you know what I mean. That's a £1 benefit that you've had just from generating that 1 kilowatt hour. So if you're doing that over a year and you're doing that on thousands of kilowatt hours, that is a hell of a benefit. And so that's where there's a different dimension with these battery storage systems now. It's not only about storing just solar power that you're getting like on a new system, it's actually making the most of your feed-in tariff system as well. So yeah, it's crazy. But we'll have a little look up at the loft, because we actually did an inverter change on this one, mainly because the original ABB inverter failed and it just needed a new inverter. So we'll go up there and have a little look at that next. So we've made it up into the loft. This is quite a tight squeeze up here. I just wanted to show you this inverter that we changed. So we actually did this before we did the battery, and then after we'd done this, we got talking with the customer about having battery storage. So this was our original project, and then the second project was actually fitting the battery. So we had an ABB inverter here, which they're all starting to go wrong now because they've been installed for quite a long time. So there was a period during the feed-in tariff where a lot of installs were fitting ABB inverters, and they're all now coming towards the end of their life. So there's more and more of those being changed. But we've fitted a Solis 3.6 kilowatt inverter here, and I also tidied up a lot of the cabling here as well. So this was kind of the original cabling, kind of came up and over there, but then I've tidied up some of the AC cabling. And as part of this, we did a full test on the solar PV just to make sure that the panels seem to be working okay. Didn't seem to be any faults on the on any of the strings or anything like that. So we've got a string here and a string there. So that's just basically a bank of panels. I can't remember exactly how they're split up, but we've got 16 panels out there. So let's imagine 8 panels and 8 panels on each of those strings. But I re-terminated all these isolators as well because none of them had bootless ferrules. Checked all the torque settings on the DC isolators as well, just to make sure they weren't over tightened or under tightened. And then also made a new plug onto this cable here so it fitted into the inverter, and checked all the connections in the AC isolator here. So when these inverters are installed away from the main distribution board, a bit like the battery, they need another AC isolator. So that's why this is already also fitted up here, and there's another one in a cupboard next to the DB downstairs. But yeah, this is working nicely now, and I think I've mentioned on the video already that the Libbi monitors what this is generating through a current transformer or a CT clamp. That monitors that down near the DB, so we don't have to get a cable all the way back up here for the solar PV. We can do all that down from downstairs. So yeah, customer was very keen to get this back up and running because obviously they've got that ground source heat pump as well as just family life using a lot of power. So I've mentioned a few times on this video that this is a feed-in tariff registered system. So that means that they basically get paid to generate power. Now, one of the other things I get asked quite a lot about is what can you do? How can you alter a feed-in tariff registered system? Can you change elements like the inverter? Is it going to mean I lose my feed-in tariff? No, no, and no. It's all good. So you can alter a solar PV system that is registered on the feed-in tariff. You can change the generation meter. You can even change the panels. You can change the inverter. But one thing you have to be aware of is that if you increase the amount of installed capacity, so if you put a bigger inverter in, if you change your panels for a higher combined kilowatt peak of panels on your roof, then you drop onto what's called an estimated feed-in tariff. So based on the size system you had. So you can't add to a feed-in tariff registered system now and gain more of the feed-in tariff. It has to be based on that original system that you first registered. But for example, we've had situations where some of the panels have been damaged. And obviously these are probably 250 watt panels out here. It's very hard to find 250 watt panels nowadays, but you could maybe get a 500 watt panel and remove 2 of the panels. So you've still got the same kilowatt peak on the roof. Same with the inverter. The original inverter was a 3.6 kilowatt inverter. This is a 3.6 kilowatt inverter. The feed-in tariff isn't there to try and trip you up. It was a very, very good scheme. So it knows that things break down. The feed-in tariff was, depending on when you joined it, was guaranteed for 20 or 25 years. They know that inverters, isolators, generation meters, even panels, some panels won't last 25 years. So it allows you to make alterations. You just can't install more than what you originally installed when you first signed up for the tariff. You can add more panels to your roof, but you can't put it through that generation meter. So you could have a, say this roof was double the size, you could put the same amount of panels on again, but you would have that either feeding directly into the Libbi that we've installed, or you'd have it feeding directly into a second inverter that doesn't go through that generation meter. So there's lots of things you can do with it. You just have to make sure that you're not increasing the amount of generation that the feed-in tariff registered system can produce, because then you would drop onto an estimated feed-in tariff. So before we have a look at the app for this Mind Your Libbi battery system, this Zappi has been one of the main reasons that the Libbi was chosen. And the Zappi has been around for many years now and is still working fantastically. And for us as OVO Renewables, we are still massive advocates for the Zappi, and it's still our go-to charger. I'm not going to go through all of the bits and bobs with the Zappi. If you are interested in the Zappi, we've got quite a few videos that show all of the different charge modes and everything on our YouTube channel. But this Zappi can basically intelligently charge this ID buzz that we're next to with just solar power, a mixture of solar and grid. You can discharge the battery into it. You can choose not to discharge the battery into it and just let the solar power go to it. There's loads of different ways you can do it, and there's no better way to integrate a Zappi into a solar and battery system than to have the Libbi battery storage system there, because it can speak directly to the Zappi, as it's all part of one ecosystem. So yeah, this 7 kilowatt black tethered unit is still one of our most popular ones. So we're going to go through the app now, and this is the same app that the customer sees. I'm going to try and describe all these little bubbles and the different settings and everything that you can see on here, depending on my access level. So I'll let you know if there's anything different in here as to what you might see as a customer, but yeah, let's go through it. So firstly, let's have a look at all these bubbles. So we've got the house at the top, so that's what the house is using in real time, so regardless of if that's coming from the grid or from solar. If we then go to the right hand side, we've got the pylon, which is the grid. So is power going back to the grid, which it is at the minute, or is power being imported, or is nothing happening with the grid, which is the one that we want to try and see. Solar PV at the bottom right, so that is what the solar is generating right now as well. So that is feeding back into the property. We've then got on the left hand side, bottom left, as I look at it, we've got the battery storage system, so in this case the Libbi. So we can see what the Libbi is doing right now and how much the Libbi is either charging with or discharging with in real time. And then above that we've got the car charger. So the car charger, if it's plugged in or not, we can see we've got the little plug with a cross through it. That means that it's not plugged in at the minute to the car. But again, if the car was charging, it would show us how much the car is charging with. Then we've got the green leaf in the middle, which is how this full ecosystem, how green is this ecosystem at the minute. So at the minute we're at 100%, which means that basically the house is not buying anything from the grid. It's running all on its own generation. So yeah, let's dive into these little bubbles now. So if we're going to the house, we can see right at the top we are currently using 1.1 kilowatts in this house. We've mentioned that we've got a ground source heat pump in here, and that is providing us with quite a high base consumption. We can see that on this graph here. We can press the little arrows to expand that, but I'm not going to do that in this case because it will change how everything looks on here. But you can see here we've got a few spikes today, but if we did yesterday, if I've got a good enough signal, we should be able to see what happened yesterday. So we've got a full 24-hour period here, and at the bottom we can see home, which is 45.3 kilowatt hours. So regardless of where that power's come from, this home has used 45 kilowatt hours yesterday. Come out of there, if we go to the pylon, this is what's happening with the grid. So have we imported, have we exported? And we can see here that we've had a 28.4 kilowatt hour import and a 0.4 kilowatt hour export. You can see a lot of that has been in the early hours of the morning, and that's because this home is on a cheap tariff overnight. And they've got an electric vehicle which they'll be charging up, and they've got batteries which they're charging up. So there's a lot of power. We can see that actually peaked at around 12 kilowatts. And then after that low tariff period, we drop down and the battery then starts to basically take over. And that's why we can see very low amounts of grid import. A little bit around sort of 7, 8 o'clock. And then after that, for the remaining of the day, it's been very low. Yesterday, so we see a full 24 hours. We can see again, we've got we've got high periods at the start and the end of the day. So the start and the end of the day, that's when we've got the low tariff window, and we've got a few little spikes throughout the day, and probably when the battery is emptied at just before 6 o'clock in this case. And we've then got the grid import again, because the grid will have to take over because the battery is empty and the solar is obviously gone, has disappeared because there's no solar power left. And there we go. So if we go into the solar power now, so we can see we are generating just around 3 kilowatts, and we've generated today 6.9 kilowatts in total. And we can see that arc. It's been a little bit overcast here, so you can see sort of around 11:30 it's then dropped sharply, and it's been quite jagged after that. If we have a look at yesterday, hopefully it was nice. I think it was a bit poor yesterday. Yeah, not a very good day yesterday. We can have a look at these in different timestamps. So you can see here we've got this week, last week, and you can see it varies. You can see there the Thursday was very poor, but the Friday was a lot better. So we can see a lot of data here, and we can see it on the desktop as well. So it's basically just showing us how much we're generating. If we go into the battery, I've got full permissions on this site, so we can see we've got 52% in the batteries at the minute. We can see the Libbi is charging at 0.9 kilowatts, and here we've enabled the grid charging, and you can press on the energy tariff to input your energy tariff, and then it'll basically take over from there to work out when to charge, when to discharge. We've then got where to get to. So this is, we want the battery to charge up to 100%. See there, we're up at, the green bar indicates where we're at the minute, so just over 50%, but the green dot is saying we want to get to 100%. So if you only wanted to charge it to 80, you just wind that back, and it would overnight, it would only charge to 80%, not to 100%. Or you can just disable the grid charging completely if you want, just by ticking that box. On the export side of things, if I press export from Libbi now, it would then stop, well, it would continue discharging, but it would go to full rate. So it would start discharging at around 4.6 kilowatts to 5 kilowatts, somewhere there. I'm not going to do that because that would be bad of me to waste some of their power, but you'd be able to press that, and then to stop that, currently you'd have to come back in and then disable the export, forced export, but you can forcibly export this system back to the grid. Powered devices, so we've just got this Zappi on this job in addition to the Libbi. So what you can actually tick is, I'll read out what this says. So besides your home, when in use, Libbi can provide energy to your other selected managed devices. So if we were happy for the Libbi to discharge through the Zappi and into the vehicle, then we can tick that box, and it means that when the Zappi is charging the vehicle, the Libbi will happily send power to it. If we don't check that box, then it won't. So that's why that direct integration is really good. We've then got a bit of an overview as to how the Libbi has been doing today. So we can see the green block is the charge. So we can see a really big chunky block at the start of the day, which is that overnight charge. We've then got an orange, so it's below the line. That is a discharge, so it started to discharge to the house during today. And then we've then flipped again to, as we've started to get into the best part of the day, to a green block again to start charging up because the sun's come out and it's been working well. We've then got the pinky purpley line, and that is showing the state of charge of the battery. So you can see we've got like a diagonal line in that first green block, and that's because the state of charge is just zooming up because we are charging that battery up at full rate as quickly as we can. We've then got a slightly slower drop in the state of charge, and then a sharper drop as it really starts to discharge back into the house. We've then got a power button, so we can turn the power off on this Libbi and just basically put it into standby mode so it doesn't do anything. Go onto the vehicle, onto the Zappi. So at the minute this Zappi is, well, I'll start from the top. So the last charge session, the Zappi delivered 7.3 kilowatt hours into the vehicle. It's currently on Eco Plus charging mode, which means that, and it's set to 100% green level, so unless the house is delivering, or the solar PV system is delivering 1.4 kilowatts back to the grid, then the Zappi will not start charging that vehicle. So the 1.4 kilowatt mark is the sweet number to remember. So unless we have a minimum of 1.4 kilowatts going back to the grid, the Zappi will not start charging the car in Eco Plus mode. On Eco mode, it would start delivering 1.4 kilowatts to the car regardless of where it comes from. So it's like a trickle charge. And then if you had suddenly 2 kilowatts of surplus solar power, then it would deliver all of that 2 kilowatts into the vehicle, and that wouldn't be buying anything in from the grid. Fast mode, it would just literally be a dumb charger and just plug it into your vehicle and it'll just charge up as fast as it can. We've then got some boosts here. we can't actually look at these until the EV is plugged in, but manual boost is basically saying turn it on for an hour. Smart boost is around, I need to leave on Monday by this time, charge up from solar power until the last possible minute, and then just start charging the vehicle. So it's basically saying do Eco Plus mode until I know we have to start charging this vehicle, or I'm not going to have enough to get to work on Monday. Scheduled charge is basically, I've got a cheap tariff between this time and this time, only charge during that period and just buy in as much as you can. The scheduled charge, a lot of companies like Octopus and people like that, they do that kind of by default through their system and through the smart integration with the energy providers. So Octopus does integrate with the Zappi, so they can take control over the Zappi and charge your vehicle up remotely based on like the Intelligent Go and all those other tariffs. If we have a look at the middle, this middle section is basically a roundup of everything. So we'll have a little look down this for, let's do yesterday, then we've got a full 24 hours. When it loads up, there we go. So yesterday, this house consumed in total 64.2 kilowatt hours of electricity, and 7.1 kilowatt hours of that was self-produced. So not an awful lot, but we're into October now and we're getting to the poorer side of the year. So that means that overall, that day yesterday was 10% green. Like I say, we had 57.6 of that 64 kilowatt hours was imported, 6.6 was self-consumed from the solar, and 0.5 was exported back to the grid, which is just the battery changing over and not always being able to keep 100% in touch with what's happening. So we'll have a look at the graph here. So this is the performance of the full property. So we've got an import showing us when we're importing power, which is the cheap times, which you can see those blue kind of shadows coming off the top of that. That's showing that it was imported, but it was at a cheap rate. And then the rest of the time on the import was just at the normal house rate, which is probably around the 25 to 27 pence. Consumed on the green side of things, so that is the solar PV that's been consumed. So 6.6, we can see that's in the middle of the day, and that might be via the battery or just directly solar, directly into the kettle, into the lights, into the fridge freezer. So a combination of either via the battery or it's direct into the house circuits. And exported, we can see around lunchtime, about 12 o'clock, there was a little bit of export, and that'll be as the battery swaps from charging at this level to this level down to this level. You always get a little bit what I call overspill, so that's what that's doing. If we scroll down here, we've then got kind of an overview of all of the devices, including the home, so what everything's used. So we can see there the top one, the Zappi in blue. You can see the blue on the chart. That's when the Zappi was consuming power, so that was on the cheap rate as we would expect as it's charging the vehicle. The Libbi discharge, that's the orange, that's below the line. So that's when the Libbi was pushing power back into the property to supply the house with power. We can see the Libbi charge on the green side of things, and that is during the cheap rate as well. So again, no surprises there. And then the home's consumption, we can see that kind of correlates to when the Libbi was discharging. So we can see there that we've got the big spikes, one at around, what's that, about 7, 8 o'clock. And we can see above the line, on the purple colour, a really high peak there. And we can also see the Libbi is maxing out below the line as well on its discharge. And similarly at around sort of 1:30-ish, we've got that spike there as well. So we can see the Libbi is operating correctly. It's just trying to keep up with demand in the property as well. So that is the Minergy app, and you can share this with other people in your house so everyone can see what's happening. Set permission levels for your installer as well. So yeah, it's just a really great app, really easy to see what's happening in a really quick way. You can see at the minute that this will be a key opportunity to show the Libbi kicking in. So you can see the solar PV is currently going into the house and there's 200 watts going back to the grid. Libbi's just kicked in now, is now charging at 200 watts. And there's still 700 watts going back to the grid, but it should react in any second now, and that 700 watts will then go back into the battery. So yeah, so the battery's now kicked in at 1 kilowatt. There's a little bit of grid import because the solar's adjusted, the house is adjusted. It's always trying to react to everything that's happening there, but you can see it's happening in real time and everything's adjusting. So it's a really quick and easy app to see what's happening. So yeah, that's why we like the Minergy app. Okay, so I've mentioned a little bit through this video about the PAS document and it relating to the smoke alarms, which to be honest is usually one of the biggest parts of the job. But the other consideration is location for your battery storage system. So the PAS document has really tried to push people to put the batteries outside, and that is probably going to be one of the safest places to put it because you've got the full protection of the building before a fire would reach that. This property here, we've not got a huge amount of ability to put the battery outside. So we've gone for the garage, which is a plaster-boarded ceiling, so it's got the fire protection that the PAS document mentions. We've obviously added the smoke alarm within this as well, which is interlinked and it's the right grade. It's also got a fire door from the garage to the property. So these are all things that, when looking at a location, not to look at the loft. The loft is now, as if you follow the PAS document, has now been ruled out of putting battery storage systems, not in exit ways. So if you are not at the bottom of the stairs or something like that, where you would, try to get out, it's just basically using your common sense to make sure that these systems don't go in an area where you need to then get out of the property fast. And if that fire has reached that battery storage system, there's the amount of smoke that we're coming out of that, you would really struggle to get out. So that's why these systems need to be considered and need to be done professionally. So the other thing that we've had to do for this battery storage installation is apply for what's called DNO approval, which is Distribution Network Operator approval. And it's just because this house has got a grid connection. We've got a grid meter, we get charged for energy that the property buys in, and this equipment, same as the solar PV inverter, needs to meet certain criteria to allow us to connect it effectively onto the grid. Most battery storage systems and solar PV systems do, certainly if they're being installed professionally and by a professional company, they will do. So it's not necessarily something the customer has to be too worried about. But if you buy some weird and wonderful stuff on Amazon or eBay or something like that, or Facebook Marketplace, then it might not be. So you have to make sure you're doing it properly. So we did that. We applied and we got approval for a 5 kilowatt Libbi inverter, and obviously they took into account the 3.6 kilowatt solar PV inverter up there, up in the loft that we saw. So that has allowed for a collective approval of, yes, you are allowed to connect this battery storage system to the site, and we know about the solar PV system that's already in. Now, the one thing I wanted to touch on is future planning. I mentioned earlier about this space here, about the customer potentially having another solar PV inverter in the future. If, when we applied for, say, a 5 kilowatt solar PV inverter, they said, look, the DNO said, look, unfortunately, there's just too much capacity on that, you can't have it, then what we can do is we can actually, through those DC inputs that we saw earlier in the video, we can actually put solar PV directly into this system. And that means that we wouldn't need any more DNO approvals, because we've already got approval for the discharge rate of this inverter. Now, one of the other things that happens sometimes is they go, okay, Oval Renewables, you're allowed to fit this Libbi battery, and we know there's a solar PV system up there, but unfortunately, you are not allowed to discharge the 5 kilowatts plus the 3.6 from the inverter back to the grid. It'd be quite rare that would happen, but it could happen. So you're allowed that system, but there is something what we call an export limit that we want you to put on the system. So they might say, look, you can have that system you're proposing, but we want you to export limit this site to 3.6 kilowatts or 4 kilowatts or 2 kilowatts, whatever. And that is just something that we input through the Libbi controller, and then it means that if that energy is needed in the house, then this could discharge at a full rate of 5 kilowatts. If, say, the solar is producing a full capacity at 3.6 kilowatts, it can go, yeah, the house needs it, I'll deliver it. If, for example, that hob was turned off, that now the house doesn't need all that power, then this would go, okay, well, I've got an export limit of 2 kilowatts, for example, or say 3.6 kilowatts. So now the house only needs 100 watts. So I'm going to drop right down, and I'm just going to let the solar power do its thing, because I don't want us to have the potential of pushing back more than the export limit. So the Libbi system will always look at all the settings and look at what the export limit is set to make sure that it's not going to affect what the grid can handle, and that's just part of getting it done professionally and getting the right approvals, because last thing we want is a bill coming through the post for a new transformer for the local area. So if you are planning to add more solar in the future, it's definitely worth looking at a battery storage system that has some inputs available that will allow you to plug panels directly in. You might never use them, you might get a second inverter, but if the DNO put the skids under that and you need to actually, you still want solar, but you're not allowed another inverter, then you can put DC directly into something like the Libbi system. So yeah, just something to consider. Right, there's another project all wrapped up. It was a really good one, this, because we had a lot of information to deliver over this video. So we had information obviously on the Libbi, we've had information on the replacement inverter that we've done, we've had a little look at the original feed-in tariff registered panels, we've had a look at the PAS document, kind of main points, so fire door, location, fire safety, smoke alarms. So we've had a lot of information in this video. So if you do have any questions, then please feel free to drop some questions in the comments, reach out to us directly, and hopefully it's given you a bit of a guide as to how battery storage systems are changing in the UK, what needs to be now considered, and also what your installer, if it's not us, should be asking you and should be advising you on all the best practice guidance out there. Yes, the PAS document isn't in the regulations, or what we call regulations, but the regulations that electricians use are best practice guidance to comply with the Electricity at Work Act, or regs. So considering all that guidance will help your installation be compliant for as long as possible, and ultimately save your family potentially for something happening. And that's what us at Oval want to make sure we do when we do any installation, not just of battery storage, but of solar PV and zappies and everything like that, car chargers. So there's a lot of information there, and hopefully you've taken some value from it. Thanks very much for watching, and please subscribe and like and share and all that jazz, and we'll see you on the next video soon. Thanks very much.